In this video, we look at the history of the periodic table and how the organization that we have today came to be. Let's begin this with a periodic table that shows the nations that discovered each of the elements. Notice that the UK, the US, Sweden, Germany, and France discovered most of the elements. Also notice that the elements discovered in the United States are mostly at the bottom of the table, and they represent what we call the synthetic atoms, formed in particle colliders. In fact, several of those were first synthesized right here in California at UC Berkeley. And you'll notice one named after California and another named after Berkeley. Okay, let's look at the early organization of elements by Lavoisier in the late 1700s. Since only 23 elements were known, a table was hardly required to organize these. On Lavoisier's table, we have elements like antimony, arsenic, bismuth, cobalt, copper, and others. But we also have some mistaken elements like light, caloric, and azote, which is phlogisticated air. Later, in the early 1800s, a German named Dobereiner began organizing elements into groups of 3 called triads, and he noticed a pattern in their properties. For example, if we organize chlorine, bromine, and iodine by increasing mass, notice that the melting point begins at minus 10 degrees Celsius, but that it increases in a predictable way. With boiling point, we see a similar pattern. As Dobereiner examined these patterns more closely, he found that they could be used to fill in missing data. For example, when calcium, strontium, and barium are organized by increasing mass, their melting points decrease. Knowing that calcium has a melting point of 842 degrees Celsius, and barium's is 727 degrees Celsius, I wonder if we could predict the melting point for strontium. Well, the number halfway between 727 and 842, also known as the mean, is 785. The actual melting point is pretty close, 777. Based on these 2 densities for this triad, could you predict the density for strontium? Well, if you said around 2.6, you were right on. So Dobereiner noticed that there are properties that can be predicted among elements when they're organized into triads. Another scientist, Newlands, noticed this pattern as well. He found that if you place the elements in order of increasing mass, every 8th element exhibits similar properties. This observation became known as the law of octaves, or eighths. So all of these attempts at organizing the elements led up to that of Dmitry Mendeleev, a Russian scientist. He organized the elements based on how they bonded. Notice that he formed 8 different groups based on an element's combination with oxygen. Sometimes 2 atoms combined with oxygen, while other times only 1 atom combined with oxygen. In some cases, atoms combined with oxygen in a 2-to-3 ratio. All of the elements didn't always fit their groups perfectly, so in some cases, he'd move an element over and leave a blank spot. Like the other scientists, Mendeleev began by organizing elements by increasing mass, beginning with the lightest and going to the heaviest. Then he found in order to put each element into a group with similar properties, he had to reorder a few of those elements. Finally, in order to make this pattern work, he left gaps in his table and predicted the later discovery of some missing elements. And not only that, but using the properties of nearby elements, Mendeleev predicted the properties of those yet undiscovered elements. And he was surprisingly accurate with those predictions. 3 of those undiscovered elements were gallium, scandium, and germanium. And this led Mendeleev to an important concept called the periodic law, which says when you arrange elements by their atomic number, not their mass, you will observe a repeating pattern of properties. In a similar way, this pictorial representation shows the property of being read repeats as you go along the element list. This, of course, is more easily observed when elements are organized into columns, like Mendeleev did. This periodic law helps us predict a variety of properties we'll learn about in an upcoming video. I hope you learned a little about the organization of elements on the table. You will find that this organized table will become an extremely important tool as you learn chemistry.